I decided to show you the results on some of the components on that Servo Dynamics drive that I have on the input section. I showed you this picture in the first video. I'm not going to go over it too much, but here are the two bus capacitors that I was talking about, and here is the three-phase bridge wired up with discrete diodes. I'll discuss these as I go along. And actually, while I'm at it, here are the new parts that I'm going to put in it. I've got a regular bridge module now rather than a discrete diode bridge. I did some testing on this with my Servo LC101, and I don't know if I really came up with any results that are actually like a smoking gun on yes, this is a problem, or yes, that's a problem. But what I did do is I tested these. I'll just show you one real quick. I won't go through the entire process. I tested these for leakage and time. Now, I'll get this out of the way. You've got a 5400 microfarad capacitor being charged up to 200 volts. It doesn't happen in just a split second for the leakage test. So what I did was I took a timer and a pen and a paper, and I wrote down how long it took to get an actual usable reading out of the LC101. What it does is when you first hit the leakage button, you get 888, basically meaning high leakage. Get this over, we can see that a little bit. It'll go 888, which means high leakage, but it's still charging, so that's why it's showing leakage. And then it gets to a certain point, and it'll show, say, 9,800 microamps. And then from there on out, it'll count down as it charges that capacitor up until you get to a final reading. So what I did was I timed how long it would take to get an actual usable reading, say 9,800 microamps, and then I timed to where I just used an arbitrary figure testing one of these new ones to where it stabilizes at a point below 300 microamps. And I'll just demonstrate here. I won't go through the whole demonstration on this one because it takes quite a while, but I'll show you at least the first 40 seconds on the leakage end of it. So basically, I would hit the leakage and then the start button, and you see how it's counting down 888 for quite a while. And it'll do this. I have 40 written on that, so it'll be approximately 40 seconds before you get a usable reading with this particular capacitor. I don't know if you can see the timer and the camera also as well. We're at about 35 seconds. So a couple more seconds here, we should get it. Yep, right there, 39 seconds, 38 to 39 seconds. Now we have a usable reading. And that isn't too far off from the new ones. The new ones were both identical at 32 seconds, I guess it was. So now at this point, what I do is I just let those numbers count down until I'm down to 300 microamps. Now, here's the difference. These new capacitors, while I was doing this, I could get it down to 300 microamps in slightly over 4 minutes. With these two old ones, at 8 minutes and 22 seconds, I shortly dipped below 300, and then it jumped right up to 420, and then at 9 minutes 15 it did again. It dropped below 300, then back to 390, and then finally I stopped to test at 10 minutes. Basically, for 4.5 minutes, these older capacitors bounced around between 500 and 290 microamps leakage, and it would get down to a certain level, and then the leakage would jump back up again. Now I don't know if that's necessarily a super high leakage for these capacitors. I mean, these are basically aluminum electrolytics, which are going to have a higher amount of leakage than most capacitors anyways. But definitely, as compared to the new ones in 4 minutes and 14 seconds for one, and 4 minutes and 20 seconds for the other one, dropped down below 300 microamps, and they were decreasing even from there. And these other older ones never did decrease below about 290 microamps, and the moment it would hit 290, it would jump right up to almost 400 or over 400 again, and it just bounced around back and forth. So there's definitely some leakage with these two older ones. Now whether that's enough to cause this, I'm going to pull this plug on this now, whether that's enough to cause this to take out a 40 amp rectifier fuse, I don't know. What I do have to wonder though, this LC101 is charging this up current limited, obviously, or otherwise if you had a bad capacitor you'd have yourself a bomb sitting there right in front of your face. So I don't know. And of course, if you're flipping the switch on a CNC machine, you're getting that full 160 volts DC pumping into that immediately, basically non-current limited. So I don't know whether initially these two capacitors have such a high leakage surge, maybe, you know, surge current, that's why it's taking out the fuses. I don't know. But what I will do is I will replace them with these new ones. Now as far as value goes, these two older capacitors, I'm actually happier value-wise with them than I am with the new ones. This one here is about 5,800 microfarads. It's rated at 5,400. Oh, and by the way, if you'll notice these aren't the correct leads for the Sencor LC101. In my one drawer here, I do have the correct leads to go with this, but I found that these cheap leads for nearly every purpose works the same, and basically I save the wear and tear on the expensive and fairly rare Sencor leads for what I need them, which is usually, I did some comparisons, and on leakage there's no difference. On ESR there's no difference. I just have to adjust the lead zero a little bit. And on value there's no difference until you get into quite a bit smaller capacitors in the mid to low picofarads. So I just use these to save the wear and tear on the good expensive ones that are getting a little bit hard to find. But anyways, value on that one about 59.30 or so, so that's good. ESR on these are excellent. Well, it might be a little bit high actually, 0.13. I didn't measure that on the other one. I did previously. I've already had these at home, testing them previous to this. I just thought I would maybe put it on camera. But yeah, actually, DSR and that one's a little bit better. I'm not sure that would, in this particular application anyways, I'm not sure, providing pure DC, how much of effect that would have on anything. Now, on the new capacitors, I'm not very happy with the capacitance on them. I just went through a reforming procedure or a forming procedure on these and held them at 200 volts each one for an hour, slowly charged them up to 200 volts, and the value on these is awful low, 4,950. They're rated for 5,600. ESR 0.02, 0.01 ohms, so that's pretty good. But the leakage characteristics are excellent on them. I'm not sure in this particular situation if the capacitance is quite as important as low leakage. obviously you need enough capacitance to have a reserve there as it pulls. That one's showing also about 4970 and rated for 5600. ESR 0.02. So they're still, I'm sure they're more than acceptable. And it's just to show you technology in 30 years. You know, those the new capacitors, the United, or the actually Nippon Chemicon, is actually rated 150 volts higher and what 200 microfarads higher, and the surge current rating on that was I think 17.5 amps as compared to maybe 7 or 8 for the original. So it's an all-around totally better capacitor, and it's way smaller. So 30 years has definitely been some improvement there. So the next step is I've got this 3-phase bridge configuration here. The one thing that I did find on this is originally, I don't know if you can see the Teflon insulators. Originally this didn't have Teflon insulators on this back section. This back section, if you look at it, is isolated from the rest of it, and it gets bolted to the chassis of the drive. Well, so what that means is there should be no continuity between this plate and the rest of the diode configuration, the bridge configuration. And when I originally pulled this out of the machine, I actually had 1 or 2 of these that were showing almost dead shorts right to this plate, and that's because of these flimsy thin capped on insulators which had failed. Now I went into the parts cage and we found these Teflon washers for another production application. It just happened to be about the right size, so now that's totally isolated. And I actually thought when I found that I'd found the problem, but it immediately took the 40 amp fuse out again. But while we're at it here, might as well do a little bit of testing on this. I've already done this as well, but just to do it on camera. So let's see here. Take this to 300 volts. And I tested each one of these at 300 volts for 2 minutes. So kind of see how, let's see if I can zoom in on this a little bit. Let's see how I've got that connected. And now you can watch the leakage readings on each individual diode. At 300 volts, we've got basically no leakage. Now I'll turn this over to the more sensitive 100 microamps max, like all other capacitors would be tested at. So we're looking at 2.2 microamps of leakage across that diode. Let's see, next diode, leakage about 2.2. Okay, number 3. So that one there is the higher one. I can't remember if I mentioned that in the previous video. I think I did. I had one that was higher, but it's 8.6 microamps. And I have the data sheet here for these diodes, and the maximum leakage current for these particular diodes, the maximum average reverse current is about 10 microamps, or 10 milliamps, I'm sorry. So we're in microamps, so I can't imagine there's any problem with that. Now I got these, I don't know if you noticed or not, but these are reverse polarity ones, so I'm not going to do the other side. Okay, so I've got, oops, that's a value. Got 6.4 microamps across that one. Again, that's microamps, not milliamps. 8.5 microamps for that one. This is at 300 volts, and these only run at well, on the input 120 volts, on the output 160 volts DC, although it does say in the drive package data that you could have a surge of up to 190 volts. But anyways, let's see, the final leakage, 2.2 microamps. So I don't see anything at all wrong with this bridge configuration, although I've decided to replace it while I'm at it. With the new brick. This is a, this is an Ixis or Isis, or however you pronounce it, 3-phase bridge. This one here happens to be rated at 1200 volts and I believe 200 amps. It's either 1200 or 800 volts. I can't remember which. I was looking at two of them and I was debating back and forth. There wasn't much of a price difference, but obviously it's well within spec. These individual diodes are rated 60 amps each, and I believe maximum voltage, forward voltage, was 350 volts. So this little bridge is well within, actually, yeah, 320 volts. 400, okay, 400 volts reverse, and then direct reverse voltage, maximum 320. So this bridge, 3-phase bridge, is well within specs for this machine. So we're going to try this out. This project's taken kind of long because mainly this particular machine is only used on a few jobs now. It's kind of, we don't really use it. We use it more as a manual machine than as a CNC machine anymore. And the operator that is using this currently has been using our other actual full manual machine. We have an old G&L, I can't remember, 340T or 350T, and if anybody's run one of those, you can understand the operator complaining about having to use it. There's levers and dials, and he has to kick over one thing and flip another thing, and it's a lot harder machine to run than what this Shibor is. But I've got too many other projects right now at work that are pressing, that have to get done, that are holding up, that are actually holding things up. So this is going to be a little bit of a back burner job, but I'm hoping this will cure the problem, and I'll maybe do a short video once I get it all together and let you know what actually happened here. And if any of you have any information you could give me, maybe you see that way that capacitor was acting, maybe you see something there that I don't, then let me know. But I have a pretty good feeling that that's what's happening. The moment you flip the power on, those two old electrolytic capacitors are causing a pretty high surge until the voltage gets high enough to that this surge current drops off. And it's gotten to a point where over the years it's probably built up to where that surge current is over 40 amps and taking out that fast blow rectifier fuse. But anyways, that's about all I have here. I just wanted to show this to you.